So, hello everyone, my name is Richardson, but I'm not English, so please have a mercy. And I will start by explaining the principle of MUSE. MUSE stands for microscopy by ultraviolet surface excitation, and it is a microscopy technique used in order to image biological tissue only on their surfaces. And without using devices such as microtome in order to do physical sectioning. The main idea is to have histology-like images only with ultraviolet fluorescence. And the principle is simple. We use UV lighting in the range of 260 to 280 nanometers. And the goal is to eliminate your sample, but only at the surface level in order to excite molecules under the sample and create a fluorescence emission. This fluorescence emission will emit only in the visible range. So we can use standard devices, standard camera and standard objective in order to read the information. And the MUSEs can allows us, to have a really simpler optical setup than confocal microscopy. You can see here an example of MUSE's optical setup, and you see that it is really simple. You only have an LED, camera, and an objective. And compared to confocal microscopy, the process in order to have your image, your histology-like image, is really faster and simpler. The only issues is that you need to have an oblique angle with your LED lighting in order to eliminate your sample and to not obstruct the light path into the objective. And here you have the results after processing a staining protocol. On the right, the purple image is the classic histological image made with HNE, which is the staining protocol for conventional microscopy. And on the right, you have the same sample, but made with fluorescence, obtained with the MUSE's dispositive. And you can see that the images are similar, quite similar. And we can give this image to pathologists in order to analyze disease. And you know what? This sample is actually a carcinoma, which is a cancer, a skin cancers. The only issues with the fluorescence image is that we can see new cells and new things that pathologists are not able to understand. So we need to, there is a need to re-educate people in order to have a better understanding of the staining protocol and the fluorescence emission. To conclude, we can say that fluorescence MUSE is simpler than confocal microscopy. It is used in a biological for biological behavior, and it can prevent surgical margins, which is really good for medicine, actually. And the only issues is that you can't go really deep into your tissue since it only affects the superficial layer, so the surface, compared to confocal microscopy. And you need to be really careful when you do some protocol. And thank you for listening.
So is there any questions or we have to? Okay.
Thank you for your presentation. Could you go back to the slide 4? Okay, yeah. In the two bottom picture, we can see that on the left picture we can see like a red part that doesn't have any equivalence on the right part. So in your opinion, do you think that Muse can allow us to distinguish better different type of cells?
Yes, the thing is, Muses can allow us to see new type of cells that we aren't used to differentiate, but pathologists are the ones that are doing diagnosis. So what they want is that they want to have an end-to-end image from histological like image to fluorescence like image. So our goal is to have really the end-to-end same image at the end. But we can think in the future, if this emerging technology is becoming more popular, that we can create some education in order to have a better understanding on new cells we are able to see.
Okay, so the last question for this talk? No? Okay. So thank you again.